What Liquisens Predict really is it's a decision-making layer over and above existing process data as well as quality data of existing instrumentation sets in water and wastewater plants, in both industrial and municipal. So that decision-making layer is actually, we don't make decisions themselves. We provide the correct type of information in real time that allows plants to better make decisions on process, to optimize things like coagulation, to optimize carbon addition into denitrification systems, for customers to optimize any kind of process that might help them with things like BOD, COD.
Okay, can you give an example? The latest example you had. I mean, last time we had the fishing
Yeah,
example with the dairy.
I
Anything
can't
else?
name names, but I can name a couple of different types of projects that we're in. So one of the projects actually is it's a municipal plant, and that municipal plant uses methanol addition, one tanker truck per week, uses methanol addition for carbon addition for a denitrification process. And by having real-time understanding of nitrogen levels, as an example, that's going to better allow optimization of that methanol. So, obviously, if you don't have that real time, you have to have your set point of the addition at a higher than what's needed, but you're going to have that excess, so it's not optimized. And by having the real time understanding of the actual demand that they need to be able to do what they need to do and get their discharge limits under control after denitrification, that they're going to be able to reduce that amount and further optimize it rather than have those high set points. So even a 10% reduction in methanol is actually a lot of money if you think about it. Methanol
Of course.
trucks, depending on where you are and what time of the season, an entire tanker truck is gonna range between let's just say 10 and 20,000 euros. So even a 10% reduction in methanol addition, you're talking about anywhere from 1,000 to 2,000 euros per month, and that's pretty significant.
And what are the sensors the customer needs to provide?
Well, they have, this particular site has over, I think at this point we've got about 100 different data points, and it's everything from what they're actually dosing as far as methanol, so process information, shutting and closing of valves, so some of the supervisory data that they currently have, but also other instrumentation, so everything from pH to conductivity to TSS flows. They do take both municipal flow as well as some industrial flow. So having an understanding of that. So there's several hundred data points that we're using that then get correlated into this real-time prediction.
But is there a basic set I need to have to provide the
No,
data?
no.
So what
So
if
what?
I have just a flow meter?
Well, if you have a flow meter, that's a little bit different. Okay, so but because you don't actually have enough data, you need to add data. You need to find data if you
Yeah.
have only a flow meter. But we're dealing with plants that have a lot of data already. So it's a matter of finding what data is needed. So everything that we do is customized. And actually, if you really look at what our core competence is we're actually, we're building a system that produces scalable customization. So we have a data engine that we input the data in various building blocks, and then we take those building blocks in a way that outputs a customized model. So our standardization for Liquisens Predict is what we call this. Our standardization is actually our data engine. That's our internal processing, but the output is a custom model per plant, per point
And
that
what if there
gives the
is a
prediction levels.
what? Okay, I got it. And what if there is a data point that is needed the operator don't have?
Then well, we don't really find that too often, but there are areas where we will go into a customer and they don't have enough data. So we need to find a way for them to actually obtain that data. So there are some cases where we will actually supply some instrumentation to be able to help them along. But the second you don't have enough data is when things are less precise. You start going actually into outlier models and things like that. The more data, the better. And in, I would say, 99% of the cases that we're working with right now, they have extensive data sets that are both process related as well as quality. Um, everything from the dairy, like we talked about before, to pulp and paper mills, to steel making plants, to cooling towers, to even municipal plants and things like this. So it's quite large markets actually for the instrumentation. So what we're doing is we're finding a way to make a decision-making layer over and above all of the existing instrumentation and data points to bring it all together into a unified stream of something that's usable for them to be able to make decisions. And that's why we talk about that's why I say that we're a decision-making layer over and above what is currently existing. And then we're also agnostic from the perspective of what instruments are there. I don't care if it's from Hawk or from Anderson Hauser. I don't care if it's a flow meter from Krona or whomever. I just need the data to be able to get that into our data engine, and for our data engine to help select through random forest algorithms, the development, um, to output those, choose what is most relevant for what needs to be correlated, whether it be COD or nitrogen or suspended solids or even phosphate as an example. So again, it kind of really come back to it as what we're talking about is we're doing two things that are intuitively don't necessarily go hand in hand in the water industry. In the water industry, overall, has always tried to standardize technology across everything. You can't really do that because every site is different. So what we're doing is we've found a way to customize per plant, but using an internal technology that allows us to scale that customization to hundreds, if not thousands, of different plants
So is that what
using a
you mean by scalable customization?
scalable customization. Yes,
So that's what
exactly.
you mean. So that means every single plant, as it is different, as we all know, you adapt your solution based on data points, and you extrapolate the data points to give them clear insights.
Clear insights into their plant. And
Exactly.
the models that we develop they don't, it doesn't mean that you can transplant that model to any plant. No, that model is for that plant. And if you put the data from a different plant into that model, it's not going to work. It's not going to work because things are different. I mean, it's you could actually have a wastewater plant that is 5 kilometers away with the same stream of wastewater coming in, and you're going to have a different output. No, I'm not talking about models. I'm talking about the water and the treatment process
Sure.
because things change, or you have different biology that just happens to grow, or whatever. So, it's very easy to standardize a membrane system or a UV system as an example, as a technology into these treatment plants. But when you come down to the big picture of the plant, every plant is going to be different. So you actually have to customize when it comes to having decision making layers.
Okay. So what is the desired outcome the operator wants if they give you a call and say, Michael, hey, I need you guys here? What is it mostly?
Uh, we can go back to another interview we had regarding the dairy we actually had a call from that specific dairy back in before Christmas, and they said, well, we've got a little problem. We just got our lab results from last week, and we were over the limit by 4 or 5 times, 3 days in a row. And here we are on Monday, and we're lucky Christmas is here. Now we're going to shut down, but we need to be able to understand this stuff real time. So the output is the regulatory parameter that they need, or an operational parameter that they need that allows them to better manage their plant. From a regulatory perspective, you have results and they're over the limit and it's 3 days later, you're screwed if the regulators already have seen it because you were over the limit. And as opposed to a technology like ours, we are allowing them visibility of those regulatory parameters in real time, where you get a great big flag and an alert saying, you've got a problem, or you're going to have a problem in the next hour. You need to take action. So it's all about
It's all about
Uh,
shutdown and money.
it's all about shutdown and also all about money. And then it's also the operation perspective as well. If you can use real time data to better optimize and not put too much energy in or not put too much chemical in or whatever, or even coagulation chemicals for coagulation sedimentation, that's money as well. And it's a better output from a quality perspective.